Hello. Okay, should we start now? Okay, fine. So moving on to the survival analysis, first we need to understand what is that. So let's get to the documentation of the survival analysis. So survival analysis was developed to measure the lifespan of individuals. It comes from a medical background. So the healthcare profession generally asks is how long this population lives or what will be the survival of that individual. So generally, so for example, the population has a nation population or a population restriction of a by disease. We need to calculate the survival of that population. So, but basically, it's not restricted only to the healthcare professional, but we can implement in also in the subscribing to a service or birth of a user to join the service. So this is the application of the survival analysis. And now comes to the censoring of what is censoring. So at that time when we make in inferences during the derivations, it is possibly that not all the death event occurred yet. So it's for example like there is an event we are calculating for event for age average age for an individual, but for a particular period of time, like for example a medical professional will wait for 50 years for each interest to study for the past away for investing, but no, we can't wait for it. So we study for a particular period of time. In that period of time we calculate the survival analysis, like here given here example, like he is maybe interested to in making decision only for a few years or months possibly. So generally, the individual in a population who have not been subject to death events are labeled to right censored. That is, we did not view rest of the view history due to the small external circumstances. So everybody clear about right censoring? Okay, fine. So it's a very important topic, right censored, because generally data analysts do not take the right sensor data, which gives the data biased data. So we need to include the right sensor also. So all the information we have on these individuals are their current lifetime duration. And now we here take example, but we will not discuss here. We have discussed in that uh, board. Now moving on the two models that we will be using in this survival analysis. Like one is Kaplan-Meier model and the other is Koch proportional model for survival analysis. So let's get back to this. One more thing I left here. Like this is example for the right sensor data. Like this is a dummy data we created here in the given in the documentation. We can read here that observe lifetimes for a period of time and further all the lifespan. And then we move on to the functions, like the important functions for our models. So like first is survival function. So what is survival function? Let t be the time, and t will can be also infinite time. Like infinite means we are not bothering about the time period, but also should be non-negative. It can't be a negative number. And a random lifetime taken on population under study. For example, we the for example the amount of time a couple married or the time takes a user to enter the web page. So this is an application of survival that we are calculating the survival of the process. So the survival function given as a S of t of a population, where S of t is probability of capital T, which is greater than a given time t. So there are some points which we will be focusing on for this survival function. Survival function generally defines the probability the death event has not occurred at time t. So it's obviously generally with the point with the word that what is survival. It generally defines the probability of a death event has occurred at time t, or equivalently the probability of surviving of past time t. Small t is a given time t, and is a random time t. So the function, so the main 3 points for the survival function is like the function should be between 0 to 1. This is the properties. So the cumulative density function is calculated by subtracting the value of the probability of the survival function and gives the CDF. And also that, which one more important thing is that survival function is not a increasing function, it always decreases with respect to time. Like we have seen that, we can see that this is a survival function which uh, eventually decreases with the as a timeline increases. Now moving on to the next function, this is a hazard function. So this is a survival function which calculates the survivability of a time person for a particular time period. But the hazard is also in calculate the probability of death event occurring at time t. So it gives the how what is the probability of a particular person to churn from a telecom. For example, here we have taken a telecom company. So we are calculating that what will be the probability that the particular individual will churn. So it's a probability of death event occurring at time small t, which is a given time t. Uh, so given that the death event has not occurred until time t, so it has not occurred, but we will be calculating for that individual which will be churning at that time. So it mathematically it denotes as the limit partial of small amount of t, which tends to 0, and the probability of capital T, which ranges from given time t and the increase of small increase of a given time t. So as a small time t shrinks to 0, so we divide with by delta t or as a derivative, and this function which is described as the hazard function. So it given as a limit of delta t tends to 0, probability of t, which t ranges from uh, given time t to small increase of delta t, and it can also be shown as the a hazard function equals that negative of differentiation of survival function. As you can see, the survival function given denoted as s of t and divided by s of t. Now we can solve using the differential equation, like s of t is given as exponential of integration negative integration to 0 to t of hazard equation with respect to dz, and which will be which is also named as a common cumulative hazard function, which is denoted as h of t. So here we can see that this is a important equation, which is which denotes the survival function. So the survival function is exponential of negative of cumulative hazard function. So here's a descriptive diagram of how we can calculate the cumulative hazard function and do the CDF. This is a cumulative diagram, all the descriptive diagram of the process. So this was the two given functions which will be uh, which will be used in the models. As now we will be going to the model. So first we'll be discussing about the Kaplan-Meier curve. So generally, let's take an example. Here is given as a political leader. We are investigating a lifetime of political leader around the world. A political leader in this case is defined by a single individual's time in office who controls the ruling regime. This political leader could be an elected president, unelected president, or monarch, etc. So the birth is the event of the individual tenure, and the death event is the retirement of the individual. So we are generally calculating the like how much time they are ruling to in the uh, so now censoring can occur. How? Uh, if they are still in offices at time of dataset compilation, or this can be also.
Akshat,
Yeah,
one question. Now, when you are reading this president example and it says censoring can occur when the person is still
yeah.
in office, so this is what this is left
No,
censoring.
this is right sensing because the event is the particular individual hasn't left that tenure, because the censoring time is we are censoring for a given time, but that person is also but is there in the office still now. So it is right censoring. Did you get it? Hello.
Yeah, but I don't know. I'm confused now.
Okay.
Okay, ठीक है.
So
So
like that we at a given time we are calculating the survival of the all the presidents, but that given president is in the office. For that president, he's in the
okay,
charge.
which means the churn has not happened.
No, no. For that person, we aren't aware of that. He has churned, but he is in the power till now. So this is
No, no.
a
That's what I'm saying. Na? So if dataset is it is saying dataset compilation 2008, that means the churn has not happened. This president
no.
is still in office.
Yeah,
That's why we are calling it right censored.
yeah.
Hmm. Okay. Yeah, yeah, Varun, absolutely okay, not a problem. Yeah, yeah, please continue, Akshat, please.
Okay. So here you given an example of Bush tenure, which begins at 2000 and officially ended at 2008 upon his retirement. Thus, the regime of a lifespan was 8 years, and there was a death event observed. On the other hand, JFK regime lasted 2 years from 1961 to 1963, and the regime official death was not observed. JFK died before the official retirement. So this is an example that is gradually redefined the birth of the events, and in fact completely flips the idea upside down by using death as a censoring event. So this is can be a example for censoring data. This is also example which where the current data time is not only the cause of censoring. There are alternative events. For example, death in office can be also a cause for censoring data. But there can be many cases for depending on the domain we are solving the problem. Now we are coming to the model, that is Kaplan estimation. So it defined as the S of t, that is pi, n of I and d of I. This NFI is the number of subject at risk of death with given time t, and this is the number of event occur d. We will subtracting the value and getting the ratio of the value and making the product of all the values, and which gives a particular value to this function.
Akshat, what is that pi I asked you that day also? It is
Yeah,
a
yeah.
summation
It's
of
a
a product.
it's a product. It's a product.
It's a product.
Yeah.
Okay, okay.
So here given a data set for all the presidents, as we can see here, and then from the library it uses a method which is Kaplan-Meier, and it uses KMF as a object for this, and then for this estimation, we use the duration as a leader. So it gives two values of observation and durations. Observation will be x-axis and the no, observation will be y-axis and duration will be x-axis. So after calling fit function method, the Kaplan-Meier has a properly called server function. So it also has a follow the styling scikit-learn technique. Like it also fits the value for a given sample of data, and then we call the plot function matplotlib, and then it gives a function curve. So this is all the diagrams which gives calculates the for a particular time. So let's take example for the given precedent. Like there are less person which uh, has a probability of 50%. Means for a timeline of 20 years, there are almost 10% of people, 10% of presidents who were there in the power for a given 20 period of year, and for a given, I guess it will be two or three, has a high percentage like one. So this is the inferences we can get from this curve, and we can divide the two classes like democratic, non-democratic, and we can define two curves for the given, and we can compare to the two um, classes, so that it can also give a relationship between the two curves, two classes and curves. So this was the Kaplan-Meier curve. Now we will moving on to the survival regression, which will use to calculate the survivability of a particular individuals. So, what is the difference between the uh, Kaplan-Meier? Is that Kaplan-Meier only uses only one particular column for measuring or comparing, but Cox proportional model, which is here, yeah. So Cox proportional model generally uses all the features like uh, like age, race, or we here is example like we are targeting that whether the person will be arrested or not. So we will be using all the features for calculating whether the person will be arrested or not. So there's here we can use the linear regression, but because we can't use linear regression because of censoring of data. So this is the point why we can't use linear regression, and yeah, it pretty same as all that linear regression, but has limitations because of the censoring. We can't use linear regression. So there are very few popular models for survival regression like Cox proportional, accelerated failure model, Allen's selective model. But for now, we will be using Cox proportional model. So uh, now data set for regression, like how we can, how we will be knowing that we will be using that regression for a particular data set. So here's the information that data set required for a survival regression must be in the format of pandas data frame. Each row of the data frame should be an observation. There should be a column denoting the duration of the observation. There may be a column denoting the event status of each observation, like 1 is the event occurred and 0 is the if censored. There are also additional covariates you wish to regress against. Optionally, there could be columns in the data frame which can be used for stratification, weights, clusters, which can be included. So this is not included in that this question.
Akshat, one
Y- y-
second. What
Yeah,
is
yeah.
what is additional covariates?
Additional covariates that whatever this is a covariate, and we can add more covariates like features to that model if we think that this has a relationship between the different covariates.
No, no. What is covariate?
I guess covariates is a features for a particular model.
No, no. Uh,
I
you,
I
you you remember those two plots I told you to
yeah,
include?
yeah, I made it.
So that is also covariance. This thing, na.
Yeah.
Anyway, don't worry. You go to the yeah, this one. This is
Two
correlation.
correlation matrix, and this is a prediction part. So it's much more give a more information insights about the correlation between the all the variables.
That's okay. That's okay. You continue. So when you come to your code, you can explain that. No problem.
Yeah, sure. So this is the data sets and how we can identify the data set can be used for regression. And coming to the Cox proportion model, so the idea behind Cox proportion model is that the log hazard of an individual is a linear function of the static covariates and the population level baseline hazard function that changes over time. So this baseline hazard function is it is with respect to time t. So it will change with respect to time, but this will be static because the covariates is always constant, but it will be changing over time. This is called a static. So the log hazard function of individual is a linear function of the static covariates. This is static covariates xi of xi. So after this, I guess all thing is discussed.
I have not understood this last part. Anybody else who has understood this last part? If somebody can
Th-
explain.
This
Uh,
function,
Akshat, if you would allow, may I add to this?
yeah, sure.
So basically, so uh, whenever you are developing these Cox proportion models, there will be some features which would be constant. Let's say if you are doing some patient survival analysis, so if you consider all the features like weight, and so all of these features will be static. These features will not change over time, like the weight, age, etc. Not like very those will not change very frequently. But let's say you are also analyzing the survival time, so the inception of the disease and the time, the current time, so this will change. So I think this is what it means, that there will be some static variables and there will be some variables which will depend on time.
Yeah, that is a good insight.
Yeah, thanks, Deepak. Thanks. That makes sense.
Yeah.
I guess we can discuss the code now. So after discussing all the points, in order to install the models, we need to install the Lifeline model package. So by using this, people install Lifeline, and then importing this libraries for all like NumPy, Pandas, Seaborn, Matplotlib, and plotting line for describing the data. So here's a here we have used the dummy data to describe the Kaplan-Meier fitter, like for this duration, like for a particular user, like there are almost seven users, and this is the duration for particular user, and this is event occurred, like he churned or not churned, yes or no. So this is a Kaplan-Meier function which fits a model, and then this calls the model, and then it uses the fit function duration and event observed, and also labels the Kaplan-Meier estimate here, and plots the graph for this. So as we can see that the
Akshat,
timeline,
sorry
yeah,
to trouble you. Again, that same question that I had last time.
yeah,
I don't know, zero is what and one is what in the
yeah.
event.
It's zero means no means hasn't churned, and one means yes, it's churned. Does that make sense? Fine. So from the graph, we can see that all the customers will be there for 2.5 seconds. Say that in a like take example, so it will be surviving 2.5 seconds, and then it decreases almost 85% till 4 seconds, and then it decreases as the timeline increases. So yeah, here is a right sensing. A data point is of certain value, but is unknown how much. The observed is minimum for of the sensing and failure times. The subject whose failure time is greater than the sensing time are right censored. This is a basic idea about what is right sensing. So now we will be using the data set for our analysis from the diagram. So this is the description of the data, customer ID, gender, whether the customer male or female, senior citizen, whether customer senior citizen or not, is 1 0 is no. Whether the partner, so whether the customer has a partner or not, yes or no. Dependents, whether the customer dependent or not, yes or no. Tenure, what is the customer has stayed with the company, phone services and online compliance, their service, online security, online features.
Akshat, your voice is breaking. I think there's something with your connection.
Wait, is it fine now? This this has like have a category like month to month, 1 year, 2 year. Streaming, whether customer has streaming movies or not, people if yes or no, mention whether interested or not. Then this t8.head function at the first top 5 column of the data, and we can see the curve send same dependence and
Akshat, your voice is breaking again.
uh, so let me reconnect it. Wait a second.